Hello guys, welcome back. Now today I want to do another tutorial called wet mixing, wet coating, in which once you spray particles and you mix them, you'll get something like this. We want to obtain something like this at the end. As you can see now I'm adding and I'm mixing, so I have my auger and then I'm mixing my particles like that. And this is what we want to get. The colors show that some volume has been added. I have the spray here. So this is what I want us to get at the end of this video. So without further ado, let's start. So we start a new project now. So we go to project. We have to always save our work. So we save and then we put it under wet mixing tutorial. So we call it wet mixing like that. Now we need to do the following. We need to add bulk material. So the way we'll add our bulk material will depend on how our custom API or our preference file is, how they are labeled there. So as you can see, I have the following. I have this is my preference file. I have my DLL, and then I have my auger origin. So this is the auger origin here. So this I drew this using AutoCAD Inventor. So this will depend on the design that you want. Now, for bulk material one, so this bulk material one, we're going to call it liquid because this is where we are going to rename. This is how we are going to rename our particle. This is where we are going to put our spray, sorry. So like that, and then we change the properties. So for the shear modulus, 1e per 6 like that. And then now we need to rename this. Rename this now to liquid. Liquid like that. And then now we need to add our spray, our particle. So single sphere, and then because it's a spray, so we put 0.5 as the radius like that. Properties you put auto calculate, so that once you change anything, you make sure that it auto calculates, and you name this particle to spray. I'm thinking of renaming these in small letters like that, just because the preference file is very sensitive, but I don't know how it will affect. Now you can go and try that. So we add another bulk material. Now this is our particle, the one that we want to spray. So we call it particle, just like that. Then under this, we also add another particle. So add shape, single sphere like that. We rename this first to particle. Just the way it's very also case sensitive because it's going to call this particle in the simulation. And then says distribution, I'm going to put 2.5 like that. And then we go here, we come here, we change the density to 2000. Please remember the density here. The density here is 1000, and this 1000 is also, as you can see in the preference file, density of fluid is 1000. So you have to make sure that they match. And also, as you can see, particle here is in small letters, so that's the same case here. So now we continue. I have my particle here. I put 2000, and here I also change to 5e power 6. Remember these values, you have to do them experimentally if you want to. Now we put our interactions. You leave them by default, but according to you, as the engineer, you decide on which parameters you have to change depending on the experiment. This is just a guide on how to do it. Now we come to liquid here. You add another interaction like that. Now we leave everything default. So properties here, we have to do how to calculate. Then we say save, and then we add equipment material like that. Equipment material, we put it like this: 2500, 0.25, 1e power 10 like that, and then we save. Please always remember to put the interactions always. Now once you put plus and then you see no further possible combinations, then you know you are safe. Now we go now to geometries. Now this is where the real work starts. Now we import first the auger because that's the one that's going to help us. Now we don't use CAD units, we use millimeters like that. Then we merge sections. Remember this is in IGS. That's how I saved because that's the one that worked for me. So you merge the sections and then We see what happens, because in some cases you'll import in STL and then it changes the dimensions. For instance, for us to know if it has changed these dimensions, we can add another geometry. Because my spring, my auger feeder, I knew that it's 400 from here, the length is 400 and the diameter, the outside diameter is 40. Therefore, that is very, very important, especially when you'll be setting the translations and the motions. And the height is important because the only way to know it is by adding another geometry, maybe a cylinder, and then I put the length of the cylinder, put it to 40, not 40, 400, and then I see if at least they are matching. Yes, they are almost similar. Therefore, that means that my auger it's in the correct dimensions as imported. Now, before we do anything else, let's put first the cylinder. We put first the cylinder. Now we transform this cylinder. We need to put some transformation, so we can rename this first into the cone. We call it cone mixer or conical mixer, whichever way you want to call it. That doesn't affect anything. Now we change the following. So we put 200 because we want to change it like that. As you can see, now we have displaced it going up by 200, and then now we need to change some of the dimensions of the cylinder so that it looks like a cone. So we come to the cylinder part and then we change radius at start, we put 80, and then radius at the end we'll put as shown 200, like that. And then the total length, we don't want we don't want the auger to be touching the top part. We want it to be moving freely. As you can see now, it's touching the top part. Now we want it to be moving freely, therefore I want to put it slightly bigger, slightly longer, like that. Yes, that's good. And now the next thing that we want to do now is to place this auger. We want to place this auger in the right spot. Now we come to transform here. Now we want it to go down. We want the auger to go down. We want it to go down by 43 millimeters. Why 43? Because if I put 45 or 50, it will this part will be outside. There is some portion that will be outside, and I don't want it to be outside. As you can see, it's almost touching the barrel here at the bottom. So, and why I'm saying that is because I want to put a degree. You see, the auger cannot work in vertical position, so the best thing to do is to put it 15 degrees like that. And remember, my reference space is still in parent, not global, so I'm going to put it like that. Now once I put it like that, if I'm moving it down, let's say -50, you'll notice something. As you can see, the red part is protruding outside. If I put 45, I want it to be outside like that. 45 is a bit better. 45 minus 45 is good. So now we are still okay. So we continue. Now we want to put some motions, and always remember to save your work. We want to assign some motions. Now the first motion that we want to do, because now we have already uh, placed it well, so it's inclined. Therefore, the first motion that we want is the rotation. We want it to rotate. Now we add motion, and then you put linear rotation. It's not sinusoidal. Sinusoidal is to go and back, but now it's linear rotation. So we put rotation like that. And I want this motion to start once the particles have settled here, or the simulation or generation of particles has completed. That's when I want it to start mixing. Therefore, the motion I want it to start at 2 seconds. This one, you leave it like that, so you don't loop it. So the initial velocity, I want to put it at 600 degrees a second. So you can decide whichever you want to do, but this is the simulation. You can change the units. If you want to change the units, maybe from 600 from degrees per second to RPM, probably you can come here to the units, and then you say angular velocity. You can change now to RPM if you want to. Now you can decide to change it to RPM and so on and so forth, and that is 100 RPM for me. So if I put it like that, then I know I'm okay. But for the purpose of the tutorial that I had created, I can put it in degrees per second because that's what I used. Now angular acceleration, you don't need to do it, and then we don't need to change anything because it's not accelerating. Now reference space local moves with the body. Make sure you let it to move with the body. Now once you do that, we need now to change the axis of rotation. So we want to see the axis of rotation. The good thing is, when I was drawing this auger, of which I'll show you how I drew it, if you want to, I made sure that the z-axis is coinciding with the axis of the shaft, the middle shaft. Therefore, if I want to put the start and the end, I can decide to put it start like this. So I want to display vector. I want to see how it looks like, the axis of rotation. Now, if I put it like that, as you can see, it's falling in place. It starts at 0, ends at 400. And you see it's local reference space. Therefore, the local axis is this, not the global axis. Now, I come down here, display vector, and then I leave everything at default. Even if I change this, it will not affect anything. Now and then I save my work. So that's the first motion that you want. The next motion now is the one that allows this auger to move back and forth. Now I add a linear sinusoidal translation. Now I come here, translation kinematic, so it will go back and forth, back and forth. So I say linear translation like that. So now in this case, I have to do like this. So also this I want to start it to start at the same time. So it starts at 2 seconds. 2 seconds like that. And then now the frequency, I want to put it like this. So how fast will it be going back and forth? 300 hertz. And then offset, I want to put offset, but I want to put the displacement magnitude. Remember when I told you, you need to know the dimensions of your auger. My dimension is, you see it's at the center point. It's at the center. I want it to go to the end almost, and also this other side to the end. But I cannot put, because the diameter here, the diameter of the circle here is 80, I cannot put the displacement to be 40, because now it will go all 40. When it goes to the 40, it will be outside, it will try to go outside the cylinder. Therefore I have to minus 20 from the radius of 80, because from the radius of 40, sorry. Therefore I have to put the displacement as 20 and 20 so that it doesn't go outside. Therefore I put the displacement magnitude as 20. And now the next thing, I leave it moves the body, and now I have to pick the direction. Now for the direction, this is how I do it. I have to pick the direction as 30. When I put 30, you see X is in positive direction, and also this other one is minus 30 like that. Then I put display vector. Once I do that, now I know that I'm very, very safe. Now the next thing that you want to do is to add the tubes. Now for the tube, for the tube, Now for the tube, we need now to put, that's where the cylinder, the spray will be falling from. We need to put it here at the top, almost at the top. Now we need to create another geometry. So we add geometry, a cylindrical. This now will be my factory. Now I call it spray factory, or the tube, because it looks like a tube. Now this is the spray factory. Now this is how I'm going to do it. So I want, first of all, I need to resize it. I want to put it the following dimensions: 20 millimeters radius at start, radius at end like that, and its length I wanted to put it like this. Something small, it's not something big, something reasonable. So something like that. And now the next thing that I want to do, so let me remove this display vector so that it doesn't, I want to remove that. I believe that you have seen the direction now, which I was talking about. So the direction of the rotation, sinusoidal translation, will be like this. It will go this way and that way, and at the same time still rotating, and you will see how it looks at the end. Now the next thing, let's remove that. So let's go now to the spray factory. Now this has to be virtual, because we want it to be to generate particles. You cannot put it physical, because if it generates particles, the particles will not fall down. I want it to be factory like that, and virtual, sorry, like that. And now we need to transform it. We need to put it at the top. So the best way to do it is just put in the z direction. So we need to put it 420 going up, because we know that we don't want it to be outside. So you can decide, if you want just for presentation purposes, you can put it slightly higher so that it looks good, but for me that place is okay. It's just for demonstration. So you can decide to push it a bit higher if you want to. So you can even put it at 450. and then you see what happens. As you can see now, it's going outside. Let me just put it at 420 like that. And remember, the reference is still parent. I've not changed it to global, but even if you change it, nothing happens because they are on the same line of axis. Now you don't rotate it, still okay. Now we need to add a factory here. So we add a geometry here. We need not geometry, add factory like that. And then now we put unlimited number per second. We leave it like that, and we want this to be produced after 2 seconds, because once 2 seconds is when I want all the particles, my particles, the ones that are being sprayed, to have been completely simulated, all of them. Therefore, and this one is for liquid, not particle. Make sure you change this. The velocity, you put it minus 4 meters per second like that, so that in the z direction they fall all the way. Now remember that 2 seconds, also the motion of the auger will start at 2 seconds. Now we save our work. Now the next thing that we want to do is the factory for the particle. Now we come here to geometry, we add a polygon like that, and then now we put this particle factory like that. And then now once we come here, we change the polygon number, we put 50 so that it becomes a circular. And then here we put 100 like that. Now you see how it looks. And then the next thing that we want to do now is to translate it or to transform it to a new position. We need to go up. We need it to go up. We are not going to translate it to the sides. I don't think it's necessary, but we'll see. Now let's go up. So in the Z direction, we need to go up to 300 millimeters. And now we don't want it to be touching the auger, so you need to push it a bit to the other side. Therefore, you can put in minus 30 like that. You don't need to twist it. Now it's okay. Now the next thing that you want to do is to add the factory here. Remember, it has to be virtual for you to add the factory. And then we add our factory here, and we need 10,000 particles. Because you need 2 seconds, total number is 10,000, target per second is 5,000, therefore 2 seconds, then that's okay. And now leave this as default, the way it is, and then the velocity minus 1 meters per second, like that. And then you can, as you can see here, we don't have anything else. We have only position, velocity, orientation, and angular velocity. Now we will add volume. We'll get volume added here once we go now to the physics. Now for us to get the physics, we need now to change the location of the particle body force. Now we come here. We need to change file locations. Now we need to change contact models. So for contact models, now we'll go where we've put our DLL. So it's wet mixing like that. And also particle body force, we also need to change it to wet mixing. And then now this other one, we can just leave it the way it is, because the other ones are just for particles, and these ones we are not using custom factories. We are just using the custom particle body force and contact models. Now we say okay, and then we say save. And now we can come here and edit contact chain. Just select one. You don't need to put both of them. Leave it here at the bottom. And then now particle to geometry, we do the same thing like that. And also particle body force can still do the same thing like that. So once we do that, we say save. Now you can go to the environment and confirm that the z-axis, the gravity is in the z-axis, because your z-axis is the vertical position. Now we come now to the simulation. I believe that everything else is okay. We cannot use 2000 R. So auto time step, no. We come here, we can change this to 40 like that, because we actually don't need it to be 20%. Now here we can come here and put something like 40R like that. And now, because if we put 2R, if we put like that, you see these cells are too many. Now we can try and put 12R, and then we see what happens. So now these are the number of cells. These are the number of grid cells. Now we don't need anything else. We don't need to put anything else, but The only thing that you can also do is to change this. And now once you change that, now you can start the simulation and see what happens. Yeah, these are mistakes that we have done. It's okay to make mistakes. As you can see, these particles are too small. They are not visible. So the best thing to do is to come here, particle factory. We have the particle factory. Come here, change this from liquid to particle like that. And then you have to make sure that now the other thing that you see volume added, volume start, liquid content, it's there. It's there, and you see this taken as liquid, the spray is taken as liquid. Therefore, we expect some cohesion here once the mixing is has started. Therefore, we have to confirm that the velocity is still fixed. But now for EDM, we have to go back to zero. You have to go back to zero so that your time step is set well. Now we go to velocity minus like that, and now we have to confirm this other one for the spray. You can decide to rename this if you want to, but for me, when I name it like that, I'm okay with that. Now we have to check this just to be certain. Now we say save, and now we can go back to this, and now we can start our simulation, and then we see now it looks good. Now we've put 10 seconds. Now nothing has changed, as you can see. Nothing is changing. Nothing is changing here. So we have now to wait until the simulation completes. So the simulation completed well and successfully. So I added a few extra seconds. So like 15 seconds. It took a total of, let's say, 3 hours. So let's go to the analyst. So when you come to the analyst, I want to change the view, the opacity. I usually like to put it at 0.6 so that I can see what is happening. And then now to have a clearer view, I come here to the cone mixer. And then instead of changing the opacity, I put it in mesh like that. And now I can clearly observe what is happening. So now the other thing that I need to come and do is the particles. So I come to the particles, then I'm going to come to specifically the particle itself like that. Or even without even going to the particle itself, let me just go to all the particles, both the spray and the particle. So I'm going to color by volume added like that. And then I'm going to put auto update. And then I'm going to say show legend like that, apply. And then these at the end, so we go back like that. And then now for the legend, as you can see, it's in scientific notation. Maybe we can try and change that. We can try and change that in a bit, but you can only change it once the simulation has started. So let us go to the legend options, and then we need to change to decimal floating. Okay, now you see the problem is 0.0000, so the best thing is to put it in scientific notation because this is in meters cubic. Now the next thing that you want to do is to carry out this simulation, and you want to change the time it takes to do so. So you want to go back like that. So you want to see if everything that we put makes sense. Now remember, the sprays will start coming from the top here, from the tube at 2 seconds. So let's observe the time. Even the motion of the auger will start moving at 2 seconds. So let's see. So let's observe what is happening. And then at 2 seconds, start mixing. And you can clearly see what is happening here. You can see that some of the particles are green. And then there is that cohesion aspect. They are getting clumped together because they are mixing, as you can see. Yes, even maybe I can reduce the speed to 0.2, and then we observe. You can observe the motion of the auger again. Yes, this is way better. You can see the auger is rotating and still also translating. So I tried as much as possible to make sure it's moving all the way. But I think you can do it better. You can make it cover the whole distance or also increase the rotational speed if you want to. So as expected, there is cohesion. So the spray particles, they are getting like they are getting absorbed because now of the DLL. Now we'll have another simulation in which we are going to observe, like we want to see what is happening to these particles. Let's color by default and then we see by uniform, like that, particle default, apply all. Now you can see that these particles are getting clumped together. As you can observe that clearly they are getting clumped together. As you can see. Now, the other thing that we can do is to export this data, of which you know how to do that. By now you know how to do this. You can come here, you export, you come to results data, and then you add, of course, configuration ID, and then the file name, let's say wet mixing. You have to put all this so that the queries become active. Now the query is active. Now you come to particle. Now under here you'll find that you'll have volume added, volume at start, and so on and so forth. So these are available because of the custom DLL. Without them, they are not there. Now, they're just for comparison purposes. I'm not going to do so much here. Just for comparison purposes, I did another simulation in which I I did not use the custom DLL. So let's go to this other simulation here. I only did it for 4 seconds. So I did not use the wet mixing. So let's go to physics and see. There is no wet mixing. Even that is for particle geometry, particle body force. It's not there. So what I did, I just removed it and I saved just the simulation and then I did it again. So as you can see, this is the simulation only for 4 seconds. I colored in red the spray particles and also the other ones. I cut the particles, the regular particles, I just left them in blue. So let's see what is happening. As we can see, the spray particles, they are not getting absorbed and the other particles are not getting that cohesion aspect. They are just floating everywhere. So there is no that mixing element. There is no that wet mixing element. Now let us color by default. Then we see. And then you can go back a bit. Yes, like that. And then we see. Now you can see that all the particles are everywhere. We can see that. So now another thing that you can do, just for investigation purposes, you can come to the analyst. We are already here. So you can come to the graph. Let's come to the graph and see what you can do. So we go to the line graph and then now we want to see if we can plot volume added against the time. So we come here to a line graph and then now we leave this as it is. Now we come to the y-axis. So we need particle, type is particle, so group is the particles, but now we need particle specifically. Now come here, we say we only need volume added, like that, and then now here we can say total, and then we create graph. As you can see, the addition of volume started at around 2 seconds, just slightly after 2 seconds, and now it goes all the way up to 15 seconds and still it's increasing because we did not specify the quantity of the spray particle. Now let us go to the other simulation in which we don't have any DLL. So we come here, no DLL, and then we see what happens. There's no DLL here. You can see there is no addition of volume, nothing, it's zero all the way. This option is there because I just exported it. Like I saved, you can save the project as and then you change some parameters, but it was taken by the software. It's still there, but it's not active. So as you can see, nothing changed. So if you have not subscribed, please consider subscribing. For those who are watching, thank you for the views and thank you for sharing these videos. Yeah, all the best in your projects. So now when you are creating the CAD file using Autodesk Inventor, as you've seen, I'm choosing the XY plane. So I have to make sure that the axis that I'm going to rotate my coil is in the Z axis, and that's why I chose the XY plane. And now you see that those are my dimensions, the ones that I've used. So you can see that I have 20 and 10, that makes 30. That is for this example I used. Now this will be a diameter of 60. Now that is for this example. Now as you can see, now I've selected my profile and now I have to select my axis. Now you select the axis now from the drop down, the Z axis, and now you choose the direction that you want. You can always swap it. Now that's the auger, as you can see. Even the pitch you decide it depending on your design. So mine I use 2/3 times the diameter of the auger. Now I have to draw the shaft that's going through all the way. So I extrude it by 400 and voila, that's it. Now is the time to export. Now I'm going to export and save it in IGS. So you have so many formats there. Yes, that's it.